Hello everybody and welcome to a new problem of this chapter, which is called the triangles problem, right? So let's read the statement together. We are given an array consisting of positive integers and we should find out how many triangles can have their sides lengths among the numbers in the array. So here in this example we have an array of length 4 with these elements and the answer is 2. Now, as you know, each triangle has of course 3 sides. Let's know the sides by A, B, and C, right? Basically, the problem asks us how many triplets are there, A, B, and C, right? In which A, B, and C are all elements from the array nums, and they can be the sides lengths of a triangle. And now you're probably asking yourself, all right, but how can I check if 3 integers from this array nums can be the sides lengths of a valid triangle? Do I have to draw the triangle in order to check that, or what can I do? Because of course it's pretty hard to make a program that will try to draw the triangle and then check if the triangle is valid and so on and so forth. No, you probably remember from maths. If you don't, that's cool, but there is an inequality which is called the triangle inequality, which has to be satisfied in order for 3 integers to be valid sides lengths. And that is, so let's write here, we have the triangle inequality, right? The triangle inequality says in words that each 2 side lengths, the sum of each 2 side lengths has to be strictly greater than the 3rd side length. So if we have this triplet, right, ABC, for ABC to be a valid triangle, so for the triplet ABC to be to form, right, a valid triangle, what needs to happen is that, remember, the sum of each 2 lengths has to be strictly greater than the 3rd one. So I can do A plus B has first of all to be strictly greater than C. That's the first thing that should happen. The second requirement is that A plus C has to be strictly greater than B. And the 3rd requirement is that, of course, B plus C has to be greater than A, right? So this is the triangle inequality. Now, knowing this inequality, you can probably come up with a brute force approach solution. I mean, it's not that hard. With our experience, we can tell that in order to count how many triplets ABC are there, we are going to, of course, try out each and every one of them, right? So set a value for A, set another value for B, and another value for C, and of course, just check if all of these happen, and if they do, awesome, we have ourselves a solution. So let's quickly see the code for the brute force approach. Okay, and here is the brute force approach. So, as I said, all we have to do is try out each possible triplet from the array nums. So first of all, I'm going to choose the first number, A, right? A, of course, has to be a number from nums, so it could be written as nums of I, right? So in order to get the value of A, I have to try out each and every possible number in nums. So I have to try out each and every possible index in nums. But as you can see, I didn't write for each I between 0 and n minus 1. And why is that? Because remember, we have to make sure that these sides lengths are distinct elements in nums, right? So not distinct necessarily in value, but I can take, let's say, this element nums of 1 to be A, B, and C, or even A or B. If I take, let's say, this 5, right, to be our A, to be a side length, then I'm going to need to have different values for B and C, right? So let's say I can take B from here and C from here, right? So be very careful, because what we are going to do in the next algorithm is that we are going to, as I said, note A by nums of I, note B by nums of J, right? So we also need an index in order to know the B, and also note C by some nums of K, right? In this way, we are choosing 3 elements from nums And one more thing, because we need to make sure that these three elements, as I said, are distinct elements, what I'm going to do is that I'm going to pick I, j, and k such that I is strictly less than j, which is strictly less than k, right? So think about it. If I choose the number in this way, I'm going to make sure that I take each triplet of numbers. First of all of those three, a, b, and c, are going to be distinct elements, right? Because I less than j less than k, and I'm going to take each triplet only once, right? So for example, if I choose the triplet 3, 5, 10, right? Let's take a look at this example actually. So basically, if I want to choose the triplet 3, 5, 10, what happens? Well, I equals 0, j equals 1, and k equals 2, right? Give me another triplet. Let's say I want to choose a triplet 3, 5, 7. All right, a equals 0, I equals 0, sorry, j equals 1, and k is going to be equal to 0, 1, 2, 3, right? Give me another triplet, 5, 10, 5. All right, I will be 1, j will be 2, and k will be 3. So each triplet of numbers can be represented as a triplet of their indices, right? Where I can suppose that I is the first one, I mean the smallest one, j is the second one, and k is the greatest one, right? So be very careful, because in a lot of problems we are going to have to make sure that we don't repeat elements, or we don't repeat a pair of elements or a triplet of elements. This is how you do it, right? Making sure that you have those indices and you set the rule that I is going to be the smallest one, j the second smallest one, k the largest one, and make sure in the for loops that you satisfy the rules that you just set, right? So what I'm going to do is, because I know that I have to choose I, j, and k, I have to make sure that I pick a value for I such that I'm going to have a valid value for j and at least one valid value for k, right? So if I pick I need to make sure that j can be at least I plus 1, right? I mean, one element to the right, and k, two elements to the right. And this is exactly what I'm doing n minus 3. Because if I equals n minus 3, I can at least have j equals n minus 2 and k equals n minus 1. If I've chosen, for example, I equals n minus 2, then j has to be at least n minus 1 and k at least n, and the element n doesn't exist, right? The index on position n, no, the element on index n doesn't exist. Then what do? I know that j has to be less than I. So of course, I try out each and every possible j, starting from I plus 1 all the way to n minus 2. Again, I'm not writing n minus 1 here because I know that I have to also have at least one possible value for k. So if this is n minus 2, k could be n minus 1, right? Like here, if j was here, k could be here. But if j is on the last position, k wouldn't have been anywhere, right? So I try out each j from I plus 1 to n minus 2, and of course I try out each k greater than j, so starting from j plus 1 and all the way to the last element. Now I can write n minus 1 as I don't have any other index to set afterwards. So what I'm doing is that here I'm trying every triplet, nums of I, nums of j, nums of k, and I have to check the triangle inequality. So if nums of I plus nums of j greater than nums of k, nums of I plus nums of k greater than nums of j, and nums of j plus nums of k greater than nums of I, then the triangle inequality is satisfied, and of course I'm gonna increment the answer, right? And of course this answer is a variable which will start somewhere here before the for loops with 0 and is going to be returned in the end. Awesome. So this is the brute force approach, right? Now that we know the triangle inequality, coming up with a brute force approach is straightforward. Just make sure again that you try out each triplet only once, right? Because if I haven't had this rule, I less than j less than k, think about it. I could have taken the triplet 3, 5, 7, right? Which is a good triplet, as you can see. I could have taken it for, I think 6 times. Yeah, I could have taken it 6 times, right? Let me show you why. If I don't satisfy this, I can have I here, j here, k here. But guess what? I can also have I here, j here, k here, right? Or other permutation of these indices, right? So each triplet can be actually taken 6 times if I'm not careful how I'm making these for loops. Awesome. Now, we know the brute force approach. What is the time complexity of it? Well, straightforward. We have 3 nested for loops, and each of them performs, let's say, at most n operations. So, and then of course we have only constant things. So yeah, the time complexity of the brute force approach here is big O of n cubed, which is of course not very great, but it isn't also, it's not very far away from the time complexity that we want here. The time complexity we want here is less than n cubed, but is greater than n squared for this particular solution. We are going to see that there are actually faster solutions, but with what we know now, we are going to look for a solution which is big O of n squared, and I'm going to throw in a hint for you. We'll also have a log n here, right? So this is the solution that we want. Please take your time, think about it. The solution is still based, of course, on the triangle inequality, but we will not fix each and every of these 3 integers, of course, because that's where the n cube comes from. We are going to be smarter about this.